All right. Well, good evening, graduate UNSY students. First, for everybody's awareness, we are recording this session. A copy is going to be made available for those who are unable to attend live. Next, for the format of tonight's meeting, I'm going to start by introducing our guests who will describe their organization's connection to unmanned maritime system technology. After, I'm going to lead a series of introductory questions, after which we'll then open up to a class-wide Q&A. I do ask that each of you mute your mics, save all your questions to the end, and make sure to use the hand raise icon to indicate when you have a question. I will call on each of you in order. I also want to note that I'm going to be capturing and sharing online links to important concepts, details, and tools that are brought up in our discussion tonight. I'll try to add those into the video notes or the discussion area tomorrow. So with that, I am thrilled to welcome you to the 16th session of the UNSY Guest SME Speaker Series. I'm Dr. Brent Terwilliger, the Program Coordinator for the Master of Science in Unmanned Systems degree at Embry-Riddle Worldwide. Tonight, we are joined by our guest subject matter experts from SeaMachines, Captain Arthur SeaMan and Steve Turano. Some quick background of our guests. Captain SeaMan currently serves as Product Manager, Government and Compliance for SeaMachines Robotics based in Boston, Massachusetts. After spending nearly a decade at sea, working his way up from cadet to chief mate on several different types of tankers in the government and commercial sector, he came ashore to join the maritime tech startup. Captain SeaMan heads all compliance activities within the company, working with governing bodies and classification societies alike to achieve product type approval and compliance. He helped spearhead the company's international policy discussions surrounding marine autonomy and was one of the captains on the autonomous tug Nellie Bly for its 2021 Machine Odyssey around Denmark. He also works with the Danish Maritime Authority as a special advisor to the International Maritime Organization, the maritime branch of the United Nations. Artie holds an unlimited master's mariner's license and is an approved U.S. Coast Guard STCW instructor. He has a Bachelor's of Science in Marine Transportation from SUNY Maritime College and an MBA from Southern New Hampshire University. Steve Turano is the Regional Sales Manager for SeaMachines. He served in the United States Coast Guard for 8 years, where he held a Federal Boarding Officer certification, as well as non-compliant vessel pursuit coxswain qualification to conduct counter-narcotics missions in the Eastern Pacific Ocean. After his time in the USCG, he captained private yachts on the East Coast of the United States and the Bahamas. He currently holds a USCG 100-ton master's license. He joined the SeaMachines crew in 2021 to collect data along the GOM East Coast with the vessel Skymark, and then transitioned to help with the successful completion of the Machine Odyssey as captain and project manager of Nellie Bly. And with that, I will turn the stage over to our guests to tell us about their organization and experience.
Good evening, everybody, and thanks for having me. Very appreciative to be here. I'm going to share my screen, and we can go through a couple of slides. So SeaMachines Robotics. We're a Boston-based company with support offices in Germany, Denmark. We work with a number of different OEM partners and product line that you'll see kind of as we run through some of these slides. But to sort of sum up who we are and what we do, we're a modern full stack company with a complete focus on advanced maritime fleet technology. We were the first to obtain major regulator approvals for the wireless remote helm and computer vision technologies in the maritime industry, deliver standard autonomous systems for ocean-going vessels, and have been one of the first to be integrated into the product catalogs of leading OEMs. Some of our major partners, over the last couple of years have been Rolls-Royce, Maersk, Huntington Ingalls, Damen, Kirby, and several partners within the U.S. government. As a little bit of a timeline, the company was founded back in 2015 by Michael Johnson. We are a venture capital-backed startup, currently Series B and actively fundraising toward a Series C round. In 2019, we had our first deployment to customers, as well as our first OEM partner. We achieved product compliance certification from Bureau Veritas. We'll talk a little bit about what the SM200 and SM300 are and what some of the products we offer. In 2001, both Steve and I had the privilege to sail aboard the autonomous vessel Nellie Bly on the 1,000-mile voyage, which we'll also talk a little bit about. A little bit about some of the technology that we offer. We'll walk through some of these in the various products that we offer, but transit autonomy, pattern autonomy, collision and obstacle avoidance, how much of this fits into a vessel agnostic product. Wireless remote helm, as well as the remote command and control capabilities. This is a quick product overview. So our SM300 has been the flagship product of the company for the last several years, the standardized remote command autonomous control self-piloting system. The SM200 also includes the same hardware as the SM200, so it does include that wireless remote helm belt pack, which gives you full command and control of a wheelhouse or pilot house from up to 1 kilometer away outside of the wheelhouse. Two products that are currently in development and have just started to hit the market is our computer vision system, Iris, as well as our SM360 platform, which is both an onboard pilot assist autonomy with advanced perception capabilities.
Hey, Artie, I want to jump in. The slides aren't changing. You might want to refresh your screen.
Okay, thanks, Steve. Is anybody seeing these?
No, it's on the start page.
All right, we can try this again.
It looks like you didn't hit present.
There we go.
That looks good.
All right, and you guys have it full screen?
It's in the presenter view with the notes, but this works just as well.
I think you're just sharing the wrong screen if you have dual monitors.
I am. I just unplugged my other monitor to hope to avoid this. We're a tech company, I promise.
I don't know. I swear this is the new default because in class the other day I went to show it and that's the way it came up and I couldn't figure out how to get out of it. Although I'm not a tech company, but
That's all
Just
right.
blame it on IT.
That's right. All right. So I'm not going to repeat everything I said, but as I just sort of scroll through some of these initial ones. So product overview, just so everyone can get sort of a snapshot of what I was talking about there. SM300, SM200, the company has been particularly focused in productizing autonomy. So we don't build vessels, we build software products and some accompanying hardware with them, and then integrate them as an agnostic solution on existing vessels. So we're unique in the sense in this sort of maritime space where we're not building the vessel itself, but rather retrofitting existing assets that are out there for companies, both commercial and government, and being able to sort of provide this level of solution to their operations. So our SM200 was sort of the first product with the SM300 that the company unveiled back in 2019. And again, this is wireless remote helm for docking, undocking. It has really taken off in the tug and barge space. So the remote helm and propulsion via the wireless belt pack. You can have control over auxiliaries and payload equipment. And the goal here is to increase productivity and reduce risk of many operations from which in the wheelhouse your visibility may be a bit constrained. The SM300 is our onboard command and control autonomous navigation system. Again, able to be retrofitted onto any vessel, and it makes it pretty unique and flexible for operators who are looking to either convert existing assets or essentially try out autonomous technology without making an extensive capital investment into a completely new vessel. So the self-piloting system allows users to command pre-planned and dynamically charted missions, gives you situational awareness via UNSY-based tracker targets, video. We're able to pull radar targets into this, AIS, IMU data via GNSS. It really is only limited by whatever sensors exist aboard current vessels today. So this is really using much of what's already on an existing tug, survey boat, or otherwise. This just highlights a couple of the key features with some screenshots of the user interface. So everything from waypoint autonomy to various task autonomy and survey grids, obstacle avoidance via our collision avoidance system, collaborative autonomy with a medallion where one vessel can follow another in a mother-daughter ship mode, and then loiter mode, very basic station keeping in a specific area of your operation. A couple of the goals really to increase crew safety, create a greater predictability and mode of efficiency, and essentially enable less systematic manual touch points. The maritime industry has always been sort of the last dinosaur of most of the transportation modes, and we have really been at the forefront of trying to push that ahead. And one of the ways we did this last year was our Machine Odyssey. It was a 1,000 nautical mile trip where we circumnavigated Denmark with the tug there in the lower right-hand corner, the Nelly Bly. The trip was both autonomous and remote control. Steve and I were the two people on board for the entire 2 weeks. And the trip was controlled and commanded from our offices in Boston by union labor. We partnered with the American Maritime Officers, and they supplied 2 unlimited cheap mates, and they were able to essentially monitor and command the voyage. The vast, we have here 96.8% autonomous, where the vessel was conducting collision avoidance maneuvers. The remote command center in Boston was there essentially overseeing that and running some communication with us on the vessel. And then that 3% that was non-autonomous was Steve and I doing most of the manual docking via the remote control belt pack, and specific in-harbor close range maneuvers. I can pause here, and I see we've got a hand raised, and I'd be happy to take any questions if there's any at the moment.
Well, it'd be best if we saved them for the end.
Okay. I'll
You,
keep
Amanda.
powering through. A little bit on our SM360. This is an onboard pilot assist autonomy system. Similar enclosure, similar technology to the 300, but now we pull in our perception. So now we're able to bring in even more situational awareness with vision-based AI and computer vision, autonomous command of pre-planned and dynamically charted mission. And again, the goal here is to provide a solution to already existing commercial fleets, whether that be tugboats, OSVs, CTVs, various offshore vessels and survey vessels. This is a quick overview of what the hardware looks like for this product. Again, similar autonomy technology integrated into this, as well as the computer vision aspect of it. I won't spend too much time on this, but the premise of the 360 is that it's broken up into 3 modes. A passive mode called guide mode, an active mode where we're calling it more of a smart autopilot, where it's autopilot plus collision avoidance as a guard mode, and then the autonomous mode, which would more closely mimic the SM300 and its remote control capabilities, but being able to provide an autonomy solution even when the vessel is fully manned. And the maritime industry is unique in that aspect, and we'll talk a little bit about the manning requirements later on. And again, you know, some of the areas that we've really been trying to focus on and bring value to customers with this increased productivity, the ability to look at decreased fuel use, and obviously reducing the amount of CO2 emissions, increasing crew safety, and trying to bring down some of the operational risks and costs. For those of you who are not familiar with the maritime industry, it's very risk averse. You know, these stats are pretty appalling where you look at, you know, 58% of accidents due to preventable human error. For those of you who watch the news, you know, oftentimes the maritime world is so wide reaching. You may have seen some of the articles relating to the grounding in the Suez Canal, or this motor vessel Wakashiko wrecked in July of 2020. And really what we're trying to do is, again, bring some of these newer solutions to the market as they already exist. The average lifespan of a lot of these larger vessels, container vessels and tankers, can sometimes span 20 to 30 years. So on vessels that are being built today, you know, we really felt as a company, we didn't want to wait and see that sort of timeline to build out completely new assets. You know, how are we able to integrate some of this technology and increase safety today? And our IRIS system, this is integrated in that SM360. It's our AI computer vision. And we really see this product, particularly the gateway to autonomy. It doesn't have the same social stigma as a lot of autonomous and uncrewed products do around the potential loss of jobs. This essentially, the goal here is to help augment and inform onboard at sea radar systems, as well as AIS and traditional sensors that already exist. And by introducing some of this new and novel technology, we're really hoping to better inform both the industry and the public about the benefits of what this technology is capable of. So over the past couple of years, 3 main products. Our SM400 has now evolved into our IRIS perception. But 3 products, 3 different classification achievements, with Lloyd's Register, Bureau Veritas with a type approval for the wireless remote helm, as well as the American Bureau of Shipping. For those outside of the maritime industry, classification societies act as a sort of regulatory body, along with the Coast Guard. These regulators act in an international capacity, similar to that of, say, the FDA here in the US for pharmaceutical company, or the Swiss Medic. These bodies are your governing and compliance bodies who are going to give your products to go ahead for installation and various approvals. It's a very highly regulated industry, as is aviation. So I'm sure a lot of you can understand where some of that comes from. A couple of our government partners, we work closely with the Coast Guard, the U.S. Navy, as well as some various confidential projects within the U.S. government. The CRADA, the Cooperative Research and Development Agreement we have in the Coast Guard, has been in place, and we've really been looking at how we can apply marine autonomy to things like search and rescue, and a lot of their very specific missions that they have within the department. There's 3 case studies here that, again, I won't spend too much time on. I want to make sure we leave enough time for questions. But the Mayor's project was focused on the vision product and really what that can bring to, again, existing current container ships. How can we further advance and improve the safety and reliability of marine navigation? This deep case study is interesting as it really focuses on those, what we like to call the 4 Ds, the dirty, dull, dangerous, demeaning tasks. This really focuses on those dull, long survey tasks where you can have survey vessels or assets out there for days or weeks or months at a time running the same grid pattern and really just gathering large amounts of data and being able to map the ocean floors. They found a tremendous benefit to using the system, and really much of the survey industry we've seen a niche market for. And in this brevet case, again, kind of leverages improved safety. We start to get into the reduced crewing, and I think ultimately the maritime industry, like many others, will see fully unmanned operations in a lot of these specific niche markets. And then the last one is Kirby, which is a remote control case study as opposed to direct autonomy. But a lot of these tugs, again, as I mentioned early on, whether it be docking or coming alongside barges, visibility has always been a major issue. So with that comes enhanced risk, and the products here offer greater flexibility to some customers. So this is a sort of an array of global customers and where they are throughout the world. So our products have touched many different countries here, a lot of different companies, and a lot of very specific needs that come up, with these various vessels. So to date, and this was probably updated a month or so ago, 109 systems out to 30 fleet customers, with commitment for several hundred coming here up in the next 2 to 3 years. A few of our customers, Foss Maritime, again, Maersk, Maine Maritime Academy, Harbor Harvest, and some of the OEM partners listed there at the bottom. So with that, I don't want to talk too much, and I apologize for the technical difficulties, but happy to open the conversation, and hope to be able to provide some insight and productive discussion for you all today.
Thank you, Artie. That was really enlightening and interesting. Gave me some points to kind of expand on with my students going forward, especially the aspect of I saw you guys mention sensor fusion and computer vision based AI. So that'll be interesting for us to kind of unpack that later. Going forward, I'm going to just ask a series of just high level questions to kind of open this Q&A up, and then we'll turn over to the students if you can all start using the hand raise icon, and I'll try to call on you in order. So my first question is, given the rapid technological change and environmental change that occurs within the unmanned, uncrewed robotics field, what tools or resources do you use to stay informed, and what are some of the challenges of sifting through the high volume of information that's out there?
From my point of view, in this government compliance role that I'm able to sort of spearhead, there's a couple of different websites and software subscriptions where I can track regulations on a daily and weekly basis, sign up for various newsletters. And within our company, as we're kind of segmented between business development, engineering, ops, product, we've all kind of taken on that task as a small startup, to try and engage and really utilize a lot of the tools that are out there today, because it's almost impossible to be able to track that by yourself. So really being able to split that up, different teams will kind of take on different topics and monitor them via email. We'll share them over platforms like Slack and some of our other teams and our different communication channels, so that everyone can kind of track and stay informed. And, we're typically posting a couple different articles a week from competitors and vendors and things like that. So at least from my standpoint, especially when it comes to the regulatory side on a worldwide basis, that has been tremendously helpful, where you can kind of filter through a lot of that information at a quick pace.
Okay. What are some of the pressing technological problems that you're seeing in the maritime space that really need to be addressed right now?
Some of the biggest ones are just the lack of turnover of basic electronic hardware. There are vessels, particularly in the US fleet today, that were built in the early 90s, late 80s, early 90s. And the way the industry is set up, capital expenditures are typically kicked down the road, and it requires a large shipyard period to do it, and funding. And a lot of these vessels, as I mentioned before, will go 20 or 30 years, but there's certainly vessels older than that are in existence. So even with the advent of a lot of new technology and new software, you're still running on products and radar screens and systems that were built in the 90s and early 2000s. So it's not uncommon to walk on a modern day vessel that was 20 or 30 years old, modern, and see some significantly old hardware that can't support anything near what we have today. I think that, and then the challenge of sort of what we see in the satellite space today, where vessels really up until 5 years ago didn't have much internet. There's very little internet connectivity. That's starting to change, but Wi-Fi is still not widespread. So you're dealing with challenging technological problems where you don't have that infrastructure backing to support it, especially on these ocean-going vessels.
Excellent. What guidance do you have for students that are looking to enter this field? What are some of the specific knowledge areas, skills, and abilities that you see that would help support their versatility and employability?
For one, there's so much potential in this field in general. There's no doubt it's not a matter of if, but a matter of when. I would say that the transportation industry in particular, carries with it a lot of different challenges beyond the technology. I think it spans into social and economic, but at our company, we've got people from all sorts of backgrounds, whether it be former satellite companies to autonomous and electric cars. The ability to sort of understand a lot of the underlying principles behind it and then apply it to specific industries. So vessels, for example, act very differently from cars, but a lot of the underlying autonomy code and the technology behind it is very similar. Same thing can be said for perception. You're dealing with a lot more motion, certainly on a vessel out at sea, than you would, say a railroad car or something like that. Planes, similar, where you're working in a three-dimensional space. But the ability to stay flexible, keep an open mind, it's great to specialize in those specific areas. But from what we have seen, the technology is so new and really just starting to expand into those fields, that the ability to work cross-functionally and learn from other areas, the maritime industry is certainly much further behind, say the aerial or even the land-based vehicle space. So there's a lot that we can look back 10 years and see how things were started there, especially when it comes to, remote control center operations and drones and things like that.
Okay. Well, now I'd like to open it up to the class. If you have any questions, go ahead, raise your hand. I see we have Chris Johnson has a question. I think, Amanda, did you still have a question?
I do.
Why don't we lead in with Amanda, just because I know you you raised your hand early, so we'll.
Okay. For the machine Odyssey, you said that the tug was controlled by 2 unlimited chief mates from Boston. Was that required by regulatory? And which regulatory agency did you work with? And what other challenges were they asking you, or what other hurdles were they asking you to jump over to make that happen?
Yeah, it's a great question. And the maritime industry is a very complex web of international business and international regulators. So the trip actually started in Germany. And initially, the German Coast Guard was against running autonomy in German waters, even with people on board the vessel. That took several weeks and months of negotiations with them to ensure that, this was going to be done safely and, it wasn't quite as crazy as it sounded. We worked closely with the Danish Maritime Authority in Danish waters, the US Coast Guard, because the vessel was being controlled from the United States. So there really is very little in the way of requirements for a bare minimum of what you need to do. Steve and I were on board to fulfill a lot of the minimum basics with things like proper lookout and others that are still difficult to justify even with advanced sensors and cameras and things like that. So the manned portion of this was regulatory related, but it was also a bit of social optics. We wanted to make sure leading in with this technology, working with the union, showing them that, we're able to work together on this and it doesn't have to be at odds with labor. And I think that was a great step forward and a great opportunity for the, for those mariners who were able to work in Boston really in a way that no other U.S. mariner has ever really experienced.
Chris Johnson.
Hey, Charlie Johnson here. I just want to say, first of all, that your remote control helm looks absolutely fascinating. I can think of quite a few situations where that might have been very useful. In particular, my questions, you actually started to touch on one of them a little bit earlier, but I'll go a little bit further. For the movement towards fully autonomous or, potentially mostly autonomous vessels on the water, how do you feel that you're going to be able to, or that the technology is going to be available to essentially fulfill the requirements of, say, Rule 5, sharp lookout? And in general, I think of like several instances, for example, like the loss of the USS Guardian in the Philippines a few years back, where the ship was navigating using charts that appeared to have a clear area, but instead there was an uncharted reef, and that was due to a chart error. I'm assuming autonomous vessels are going to be using digital charts or some similar medium in order to do both route planning and reactions during their movement. Is there a way that we can work with that? I think about a lot of places in the South Pacific where you read sailing directions and it says, hey, the position of this island may be up to a mile in error. And going along with that too, sort of the maritime version of the Tesla question, do you hit the bystander or do you take the crash? When I think about operating in extremis, one of the more interesting things is the decision on how you're going to proceed. A turn away from the vessel at short range may prolong the time to collision or CPA, but a turn towards may result in a glancing blow and provide less damage to both vessels when collision is unavoidable. How will autonomy be able to analyze the situations, or where do you see the movement towards autonomous vessels in these types of situations?
Thanks for the questions. So the first one, I represent the country of Denmark on their working group at the IMO for the Maritime Autonomous Surface Ships, or MASS, MASS working group. And that group looks very specifically at a lot of what you just said. There's a lot to unravel in the maritime world, things like role of the master or captain of the vessel, who, unlike in any other industry, has full authoritarian command over a vessel legally. So, a lot of legal questions arise with that. Well, where is this person on board the vessel now? Are they in a remote control center? If they are in a remote control center, are those people considered seafarers? Do they need to have the same medical and regulatory requirements that licensed mariners today have? So there's certainly more questions still in that area than answers. But when it comes to autonomous technology specific to the maritime space, like any computer, it's going to be garbage in and garbage out. It would probably surprise many of you to know that there's still many ships out there today that are operating based on paper charts that are printed and corrected, kept in a drawer, hundreds, if not thousands of charts in a catalog on some of these commercial vessels. As this transition into electronic chart display information systems, ECDIS and ENCs, begins to further progress, paper charts are being discontinued in the US. NOAA had issued, I believe it's 2025, they'll no longer issue any paper charts. So as a lot of this transition occurs to the electronic chart basis, I think we'll start to see more improved data and reliability. I think you'll always have those edge cases, where you have a what if, but you can kind of compare it to what it is now. If a modern day mariner is using a paper chart and there's something uncharted, the odds are they're going to likely run over it. So it really depends. Can you bring a level of equivalency into the autonomous domain that you currently have or have had, say, over the last several decades with modern day navigation and charting systems? And then when it comes to items like in extremis, when it comes to programming these vessels and working with the code, a real fundamental underlying theme is safety and being able to sort of program the slow, safe speed, conservative maneuvers. When in doubt, make a round turn. The opposite of, say, what sometimes in stressful situations people may do today when they want to speed up or cut in front of somebody, or maybe take that maneuver that sometimes is emotionally fueled or stress fueled and really dial it back. So there is an ability here to sort of implement controls that in the real world today may not be there when it's only the human operator. I think here, particularly when you have remote command, you have an ability still for a human to step in these edge cases. But I think that underlying principle of safety and slowing down and conservative maneuvers needs to always be thought of.
Thank you so much. I appreciate it.
Siobhan?
Hi there, you hear me? Hello?
Loud and
Yes,
clear.
can hear you.
Got it. You had mentioned that one of the challenges is the lack of turnover of new vessels, new technology to implement it and kind of sync with your software solutions. Is that across the board to all the industries? Would the defense industry, government customers have more resources for you to build new hardware to go with your software solutions?
Yes, most definitely. Certainly the government sector has a lot more funding at their disposal than most commercial companies, and it's really run on a different premise. They're funded by Congress and even international governments, being funded by various defense acts and bills, whereas commercial companies are out there to make money. They're trying to move products and goods from point A to point B. And essentially anything that's not required to justify paying for that as a business, they're going to ask, how is this saving me money? How is this making things safer? At the end of the day, the commercial industry is driven by that bottom line. It's driven by, the goal to make a profit, whereas the defense industry is going to be a bit more willing to look at more advanced technology in fear of missing out for what potential enemies and foes may be developing. So they're always trying to stay on that cutting edge. So in terms of early adopters in the technology space for marine autonomy, the government is definitely at the forefront there. They also don't have to comply with the same level of regulations and carry the same amount of risk that a lot of commercial and private industry customers do.
Awesome, thank you.
Eric?
Hi, you mentioned for your 1,000-mile trip there that basically you guys had to do the last part for docking and the very end there. I'm just curious, how far into the future do you see where some sort of autonomous boat will be able to actually dock and do that entire voyage itself?
So that's an interesting question, because it's not so much a rather a limitation on the technology as it is, our company's stance on that issue. We're really trying to productize autonomy in an area that we know operators need help the most. And often docking, close quarters maneuvering, when it comes to timing of the voyage, you see in the 14 days, it was only 3%. On long oceanic transits, it's such a small period of time, often taking only an hour or two, when you're looking at maybe a 2 or 3 week voyage or something like that. So for us to be able to try and provide that level of value in a single product with, trying to balance the effort and resources that go into it, our focus has really been on open ocean navigation, outside the harbor, because again, that's the vast majority of the time where these vessels are operating. There's certainly capabilities to do docking and undocking right now, but when operators look at that, it's, what are they willing to pay for and invest in? How much risk does that incur? Boats are a bit different from ships, just in the size and scope and efforts that they're conducting. A lot of ships utilize pilots and port captains to help maneuver these vessels in and around. So it was really a market that we didn't see a tremendous need to penetrate right now. There certainly are companies out there that are focused just in that space, particularly in the recreational world, where you have a lot of private boats and maybe inexperienced boaters and mariners who can use help in that regard. But it's definitely a different problem to solve, for sure, in those two industries.
Awesome, thank you.
Manny?
Hey, good evening. Can you hear me? Hey, awesome. Hey, thanks, Captain SeaMachines. Appreciate the time and certainly the brief. Took a couple notes here. First off, I'd like to say I thought the wireless remote helm is very cool. I know somebody else mentioned that. It's definitely a neat idea, and I like the visual that you displayed there during the presentation. I work in the government sector. One of my focuses is naval integration from the Marine Corps side. I work a lot on amphibious L-class ships. So the things that you say with safety, risk aversion, and a lot of the limitations that you discuss regarding availability and maybe the adoption of technologies very much resonated with me. Hopefully a lot of those things speed up, not so much just an experimentation, but the ability to conduct installs on ships and get capabilities out there speeds up. I know the Navy's really working hard to do that. Hopefully we see some good things there. So my question, looking at some of the stuff that you guys put out there, is really focused on the communications architecture that supports some of the design that you have. I know I'm very familiar with some of the environmental conditions, particularly well out at sea, from a communications perspective, knowing that latency and bandwidth, primarily latency, are an issue. It appears from the briefing that you mostly focus on the littorals. Have you guys done any experimentation outside the littorals in deep water? And what communications architecture do you guys rely on now, or you plan to work on?
So we haven't worked too much in that regard. I was actually met with a satellite partner today in our offices in Boston, and this is really where we lean on some others for some assistance with this. Our primary focus is the autonomous navigation systems, and there are certainly a lot of components that feed into that and that are integrated with that. But communications is probably the #1 aspect of it, where our system can certainly interact with, but we're not looking to sort of dive in and manufacture and develop that. We see a lot of certainly tremendous potential here in the modern day space race when it comes to satellite communications and the voice over internet phone, and the availability of a lot of these satellites and low Earth orbiting, platforms that are available, especially on the commercial side and the government sector, certainly even more. But yeah, this is certainly an area that I would say we strongly rely on partners and collaboration across different industries to sort of come up with some of these ideas, whether it's a voice over internet VHF repeater, voice over internet phone, as I said. Those are really those niche areas that we're not looking to tackle those problems alone.
Cool. Thanks very much for your comment. Yeah, I acknowledge it's a very challenging environment. It's yeah, definitely some cool technologies that are on the horizon right now. I'm looking at optics and definitely MEO LEO solutions for what it is that I look at. But yeah, cool. Thank you.
Yeah, absolutely. Yeah, I appreciate the feedback and hope we cross paths in the near future.
Jesus.
Yeah, same.
Okay, just unmuting here. Yes, no, thanks for the presentation. And I was more curious as to basically how long does when you guys go to modify one of these vessels, how is it like a quick transition? And then along with that, like, how does it affect, for example, crew interactions or going from an automated process to basically to the automation? Like, do the group dynamics change, or do you guys do follow up as far as like training or get feedback on how the performance of the new upgrades affect the vessel?
Our deployments on the existing systems today are incredibly quick. The Machine Odyssey, for example, we had purchased that tugboat from Damen, and within about 2 weeks had it in a shipyard for painting and some retrofitting of additional sensors that we wanted to put on, some cameras. And it was about a week after that, in total 3 weeks, to take this tugboat from commercial small harbor push tug to a nearly full autonomous vessel, where you have remote capability and can control this thing anywhere in the world, and can conduct its collision avoidance maneuvers. And that is a major asset, both commercially in terms of downtime and the ability to work on existing vessels and assets, as well as in the military when they're looking at at options. Oftentimes, the defense sector, these things take months and years and sometimes decades, to build some of these major platforms, to plan it out, to get the funding. And this is one of the biggest advantages to being a small VC-backed startup. We have an ability to move very fast. We can fly people down next day. There's a lot of autonomy within the organization for people to make decisions and really execute on a lot of those. So, I would say on average 2 to 3 weeks to get these systems installed, up and running. Follow, the design process behind a lot of these, work with these product development teams on a day-to-day basis. And the Lloyd's AIP that we received from the SM400, we worked very closely with Lloyd's human factors experts, and we do some work on that front in terms of seeing how the user interacts with the system. Obviously, there can be tremendous pitfalls when it comes to over-reliance on technology, especially new technology that they may not be used to using. The assumption that your GPS data is good and the chart data is good. So really ensuring that the technology is used in a safe and effective manner, and that these operators are aware of the potential downfalls that come with some of this. So there's definitely an aspect of training. The installation process, if anything, is probably the easiest. The systems are simple and fairly intuitive to use. Within a couple of hours, you can click around and really know your way, especially if you're used to using modern navigation systems. But you're right, long term, it is that mindset of understanding and sort of developing a relationship with a lot of this new technology, because it becomes a digital partner in your wheelhouse that you didn't otherwise have.
Right, yeah, and the reason I kind of mentioned that, I was a C5 engineer, and we went through basically an upgrade from analog to all digital, right, to where a lot of processes became automated, and so we kind of became more of just monitors instead of kind of operators, just kind of seeing like the system, yeah, it's doing everything that it needs to do. But then as you mentioned, as you're progressing the line, all of a sudden new issues come up, and then you have to kind of adjust and reintegrate into like, okay, how are you gonna deal with the automation to figure out what it's doing? So yeah.
No, absolutely. And modern day, these modern day bridges and wheelhouses of commercial vessels have had to install what's called a BNWAS system, or bridge navigation alert watch system. And this is without autonomy, just because so much is automated and there is autopilot on these vessels. And, you know, so much is integrated and connected that operators would just fall asleep. So, you know, now you have operators, whether on board or remote, you want them alert and attentive and still in the loop per se. And a lot of those issues and features have started to come about in some of the technology as sort of a, you know, for those familiar with Tesla, like the hand on the wheel function, and, you know, ensuring that the operator is still there, coherent and aware of what's going on should one of those edge cases arise. And I think you'll see a lot more of that as some regulations start to roll out across a lot of different industries. You'll see that issue rise up because it's a very valid one.
Okay, thank you.
Thomas.
Good afternoon. Just to let you know, my normal day job is cybersecurity. And one issue that I've always kind of been concerned about is as we keep moving systems to the cloud, or, you know, communications link for these autonomous systems, it seems like that there's potential to increase vulnerabilities to cyber attack, either from state sponsors, terrorists, you know, hackers, etc. Is this something in consideration in the development of your products?
Absolutely. Not only is it in consideration of development of our products, but this is one of the top priorities for you know, organizations in the U.S. government, like the Coast Guard, when it comes to regulating commercial vessels, or the Navy with their own operations. You know, we work with several third-party vendors when it comes to, you know, cybersecurity hardening and monitoring, as well as different certifications. This is another interesting area where a lot of the technology really outpaces much of what's regulated. You know, and then you have cyber secure and cyber compliant. And as you well know, they could be very different things. You may hit everything on that checklist or in that manual and think you're good, but you know, really being secure and hardened and having a product that can be tested and put through the runner, particularly when it comes to these remote operations. You know, our current product offerings and really what we're pushing here, what we see a market for with the onboard autonomy, comes with slightly less risk, but essentially anytime, as you know, you're connected to the internet, or you know, you're put online and you have that ability for someone from the outside to get in, it's that IT over T lap, and a lot of that OT on board these vessels includes ballast systems and cargo systems and main engines. So this has been a priority at the International Maritime Organization, and again, another area of the industry that's going to expand exponentially over the next decade that, you know, 10, 20 years ago was really very minor. So it's really been interesting to see some of these ancillary sort of industries grow within, you know.
Have you, or do you know if the industry is actually looking for where the threats could be generated? No, where it's not necessarily a technical, you know, my belief, something, if it's going to be hacked, it's going to be hacked. But my challenge is why? Who is doing it? What is the goal? What is, you know, what indicators are possibly out there? Is that something that the maritime industry is looking at to see where the vulnerabilities could be coming from? Who are the threat actors?
Yeah, most definitely. And I would say the top two that I've heard, and much of it depends on the mission of that vessel. You know, so if they're carrying oil, where is that oil coming from? You know, state actors obviously are probably number one on that list, particularly in areas prone to piracy. You look at corridors in the Middle East, like the Gulf of Aden, the Indian Ocean, the Persian Gulf. there's a lot of oil, a lot of cargo that moves through those areas. You know, modern day piracy as we know it today is likely going to look very different 10 years from now, you know, when someone can potentially try and hijack or pirate a vessel virtually rather than even needing to be there physically. And the second one is, you know, sort of what we've seen introduce itself into the transport industry with ransomware and the, you know, the Colonial Pipeline attack. And I don't think that's going to be a one-off, and I think you'll start to see more of that as well, particularly in high-value areas and very public-facing industries like the maritime industry. You know, you see things on the front page with, you know, as I alluded to earlier, the Suez Canal. But I think you'll see that across all transport sectors because, you know, they are vulnerable, and it is a clear pinch point. You know, you can't shut down world trade, but you know, the ability for these ransomware groups as well to try and leverage these multi-billion-dollar corporations and make money off of that, I think is a real threat, and one that is definitely being taken seriously. But you know, it's a classic, you don't know what you don't know. So it's an ever increasing training and hardening, and it's a dynamic obstacle. It's one where you'll never be at 100%. You can always only strive to get there.
Thank you.
I believe Eric is next.
Hey, Artie. I got a couple high level questions and some lower level questions I can ask after Siobhan gets done with hers. One of the things that I was wondering, you'd mentioned that when you first started doing the, I can't remember what the name of the ship was, but you were doing it autonomously out of Boston, and the Germans were against allowing you to do it. But once you get outside of their waters, now you're in international waters. Who actually controls the regulations on the autonomy there?
So that's the group, you know, that I've mentioned a few times, the International Maritime Organization, the IMO, based in London. You know, they are a wing or a branch of the United Nations with, you know, 170 some odd members from all over the world. And every country essentially that is a member has a delegation. They have a single vote. So it is structured very much like the UN. And that MASS, MASS, or that Maritime Autonomous Surface Ships working group, from which I closely aligned with Denmark for that, is looking at this topic specifically. But for perspective, you know, they don't foresee having a mandatory rule in effect for international waters until sometime in the realm of 2028, which means really before then it is sort of the Wild West. If you can comply with existing rules and regulations and make a strong enough case, you know, there's nothing hard and set in stone. They're hoping 2026 to have a non-mandatory code, and then by 2028 to 2030 really start to implement you know, some mandatory rules and regulations in there.
Okay. And then I had this one other high level thing. It basically, I come from an unmanned aircraft system world, and we call it DAA, detect and avoid. You were talking about your SM60 system that had the surveillance technology on it, which is basically looked like a detect and avoid type of technology. And I was wondering, how does that work? Because with a drone or UAS, detect and avoid is rather quick, but with a large ship, it is not. So how does that work?
Yeah, collision avoidance in the air versus on the water, I would imagine is certainly very different. You know, luckily we're not operating at hundreds of miles per hour. You know, high speed on the water is probably 40 knots or about 45 miles an hour, and that'd be considered very high speed. You know, the average vessels are probably moving somewhere in the realm of 15 to 20 miles an hour. So when it comes to radars and perception systems like our IRIS computer vision system, there is time. You know, most of these things, quick scenarios, occur in a matter of a minute or two. And long scenarios, particularly ones on radar screens where you may be conducting a collision avoidance maneuver, could sometimes be 20 or 30 minutes out. The constraints are obviously you're on a two-dimensional plane where you can move left, right, stop, reverse, as opposed to changing altitude or things like that. So it is a unique aspect. The challenge, particularly when it comes to even instruments like LiDAR, which is, if it's used in the autonomous vehicle space, things are not steady. You're moving on the vessel, the environment around you is moving dynamically, and then your target, wherever, or targets, typically several of them, because Murphy's Law, it's never just one thing. Everything is moving all at once. So the ability to track that and sort of maintain situational awareness while all that's going on is challenging. And that's probably the largest technical challenge when it comes to perception systems in the maritime space is, all of those different motions, the 6 motions on the various axes of roll, pitch, and heave, yaw, and sway. And, and really being able to dial that in so you're able to lock on a target and then avoid it. And a brief backing, I don't know if it was mentioned, but we've compiled a database, a machine learning database of over 50 million annotated images. And this image database is then broken down into categories and subcategories and includes everything from power-driven vessels to sailboats, exposed reefs, buoys, navigational aids, whales. We're really trying to detect as much as possible, really limitless in size around the vessel for items that most of which I just named would not come up well on a marine radar, a lot of these smaller items. So really fill in some of those gaps from what existing sensors provide and be able to complement those, not replace radars and and a lot of the AIS and computer systems that are on there today, but hopefully enhance and further improve that.
Okay, yeah, that kind of, and there was we occasionally use a software called YOLO, which is you only look once, and you showed me showed one of the slides, and it kind of looked like a YOLO type slide, and I was kind of wondering if it was somewhere along those lines, and so that basically that answers my question there. So
most definitely, yeah. I'm not familiar with YOLO. One of the things that we're particularly careful of is to make claims, especially when it comes to the technology, that it's a first, because unmanned aerial systems, much of what the military has done, and even autonomous vehicles, the general autonomy stack and autonomous technology is not new. But what is new and novel is its application specific to the marine domain and specific to platforms that are very different and very diverse. Tugboats handle very differently than pontoon boats or fishing boats and container ships. So the breadth in size and scope and shape and vessel dynamics on the water, and that marine engineering aspect of it is really what takes technology that has been around for some time now and certainly has advanced in a lot of the other sectors. And it's really, that's the new and novel part about it in the marine space.
okay, fantastic, thanks, appreciate it. I'll let others talk now.
So one thing I'd like to just connect some pieces for you all on that will relate to other domains and technology that we talk about going forward. Already mentioned, roll, pitch, yaw, sway, heave, and surge. The way that maps is, if you think of an inertial measurement unit, an IMU, and then what's called the right-hand rule, X, Y, Z, the different axes. Roll, pitch, yaw, those are rotations about those axes, while sway, heave, and surge represent accelerations in each of those axes. So that's important because all unmanned systems, regardless of domain, they all incorporate that technology, because that's what you use to determine where the mechanism is heading, what forces are being applied to it or occurring. And then when you couple it with something like GPS, you can do predictive localization or path planning. You can do trajectory determination. So it's important to keep that in mind. Another area that I personally had some experience with this and was not unmanned system related. It was actually 6 Degree of Freedom simulator development, because they also use those same terms and concepts, because that's how you replicate movement in a simulated world. All right, I think Siobhan, did you have a follow-up question?
Hi again. Yes, I do. Would you have any stories of notable challenges that your team overcame? Especially interested in challenges that were not identified during the design phase of your solution, but surfaced during test and evaluation, if you do any before you integrate it into a vessel.
Yeah, that's great. The one that comes to mind the quickest, because I was so heavily involved with it, is going through much of the type approval testing with our products. These classification societies have very rigorous standards when it comes to emissions testing. EMI, environmental testing, everything from saltness to fire retardancy, hot and cold testing at various temperatures. And certainly during the first couple of iterations of the initial 200 and 300, a lot of these things you take into account in the design phase of a product and you start to advance it. But it is difficult, especially with a small company, limited resources, and just a very limited lab and sort of garage space that you're working out of in your first couple of years, to anticipate much of what you may see when you go into an EMI chamber and you're testing at various frequencies. And that definitely poses a challenge, and I think it would for any electronics manufacturer, out regardless of autonomous functionality or not. And that's tricky. The emissions chambers and the ground plane testing, and a lot of what we do, especially on a complicated device that we have, where the SM300 has 32 inputs and outputs, and you're really chasing a lot of potential there. And for us, I would say that was definitely a challenge, and it's one of the reasons I'm so proud of the regulatory approvals that we had, because it really is an ability for the team to rally. You're working with everyone, supply chain and manufacturing, the hardware engineers, the software engineers, the product team, and everybody really needs to come together to not only figure out a solution, but implement it, get it through that testing process, get it in front of regulators and pass. It's a very objective process. It's not one of these sort of subjective arguments you can put in front of someone and pass. It's you either meet the standard or you don't. And after millions of dollars have been invested into products, and they begin to fall short in certain things, you've really got to be able to pivot quickly and efficiently to conserve resources and make sure you can get products out the door and delivered.
Awesome, thank you. And do you guys have your own test facility for those to overcome those challenges, or you rely on existing test labs?
We don't, being a company of less than 50 people, a lot of these facilities, we definitely rely on third-party labs, and time and resources for them are also very limited in a lot of these test chambers, where they may book out 4 to 6 weeks or so in advance. So when things go wrong, it often can delay you more than just a couple of days. You've got to get back in that queue to get back on a schedule to try again on your second or third go, or make some changes to figure out what's going on. So yeah, we rely on third-party labs, and we're lucky in New England, and particularly in the Boston area, to have quite a bit of that around a lot of the universities and technology centers up here in the Northeast.
Got it, thank you.
Hey, Eric, did you have a follow-up? Okay. So class, I want to thank each of you for joining us this evening, as well as a huge thank you to the SeaMachines team, Artie and Steve. This has been a very informative and enlightening session that is going to help us to better understand UNSY maritime systems, both their uses and challenges. Remember, to receive credit for participating this week, you're going to need to develop a brief overview for the Module 3 discussion. You'll need to post that by Sunday, and you don't need to add the typical 2 responses. For UNSY 501, identify that you are in attendance and describe how our guest SME's organization uses or has developed unmanned technology to advance the field and or improve capability. For UNSY 502, describe how our guest organization is helping to advance technology or capability, including possible intellectual property and potential protections they might use or consider to safeguard their innovations. Both classes should make sure to discuss any new information that you were not previously familiar with and how your understanding of the topic has improved, especially if there's a way to connect our guests' observations, experience, or technology uses to maritime UNSY support. With that, thank you all for coming out tonight. I'll stick around for a couple minutes if anybody has any questions regarding 501 or 502.
Brent, I did have a question just from standpoint, you mentioned the modeling and simulation. How did you do that? Because that's what I did for most of my career. So it interested me. So
yeah. So here, I'm going to stop the recording here.
Sure, no problem.